All right. Hi. Thanks all for coming to my talk, Observability and Debugging Microservices with Linkerd and Conduit. I'm Franziska. I'm a software engineer at Buoyant, and I work on service meshes, most particularly Linkerd and Conduit. I think we can all agree on that debugging microservices is really hard. And that is because also services are owned by different teams and the application logic is split across service boundaries. Services are comprised of many running instances, and those instances are potentially being rescheduled at any moment without any advance notice. And as a result of that, the tools that used to work for debugging monolithic applications don't really apply in this new microservices architecture. And we see a new set of tools popping up at every conference we go to, where you have to find something that helps us debug our applications. So we've got Fluentd because we used to get away with just adding logging to one of our instances, and we could kind of get a good idea of what was going on. And with this new architecture, this doesn't really work anymore because the logs are distributed among many services. We've got Prometheus and we have OpenTracing, because you used to be able to see the life of a request through one instance, and this also changed with microservices because each service calls another service, and so OpenTracing kind of lets us trace the services from start to bottom. One of the words that keeps popping up and trying to help with this new architecture is the service mesh. We still get a lot of questions on what is a service mesh, how does it help me, do I need it, what can I even do with it? Like, it's becoming this word, but it's not quite clear yet just because it's really new, like what does it all entail? So I want to take a couple minutes to go over that and talk to you about what a service mesh is and how it can help you to debug your applications. So a service mesh is a dedicated infrastructure layer, and it's adding reliability, security, and visibility to a cloud-native application. And it does this by managing the service-to-service communication at runtime. It also provides many other features, such as circuit breaking and request routing, security policies, et cetera, et cetera. The focus on today's talk, though, is how to use a service mesh to debug a microservice architecture. With that, I want to talk a little bit about what consists a service mesh of. And we have a control plane and a data plane. And the data plane is usually implemented in a lightweight array of proxies. We can see here, if we're talking about a Kubernetes-specific application, we have all the applications in a pod, and then we have, as a sidecar injected, the blue squares, which resemble the conduit proxy, or not the service mesh proxy, sorry. I'm going to talk a lot about conduit later on. Yeah, so they're all connected. And then we also have the control plane. And the control plane is kind of the user's gateway to the hot path where the proxy sits in. It's what you as a user interact with to get a UI, to see the metrics, to set up policies that you're going to deploy. Now I want to talk about the life of a request, like one request from service A to service B, when it's being routed through a service mesh. So here we have two pods, and we have service bar and service foo. And bar is calling service foo, but what happens is that bar calls the proxy that is deployed alongside its pod, and then that proxy calls pod 2, the proxy that sits within pod 2, and then the proxy in pod 2 forwards it to the foo service. And because of where the proxy is positioned in this request, it knows a lot of things. It knows the latency of things, as in like, how long did the request take to get from bar to foo? It also knows whether it succeeded or whether it failed. It also knows how many of these requests happened over a recent time. it knows the origin, like the identity, who sent the request and who is the receiver of the request. What instance was the receiver of the request? It knows a lot more. It knows whether or not it was retried, what instances it went to, as I just mentioned, and many other facets of things. So now to the question of how we can use a service mesh to help us debug our application. And that is because where the proxy sits, it gets all this information, and aggregating that and using it allows us to paint a really, really specific picture of the application. And that allows us to really easily display top-line metrics, such as success rate, the latency distribution, and the request volume of each of the services that is running on a service mesh. And that is tied to identity, including the caller and callee relationships, knowing who sends a request to whom. Service mesh debugging or microservices debugging is fundamentally different than like a different class of diagnostics information. We can know and we want to know of what is the success rate of the foo service. Which service calls foo? Which services, plural, they might be multiple. What is the success rate of foo when it's called by a specific service, bar in this case? Because that might be different than a third service that's also calling foo. And of course, what's the request volume, latency distribution, all these things are very important to us as service owners. And with a service mesh, we can do all of that without having to modify our application at all. It doesn't require any changes into application code. So I want to talk a little bit about Conduit, which is the demo that I'll be running in this talk as well. And Conduit is a completely open source service mesh licensed under Apache 2. We built it from the ground up for Kubernetes. And for that reason, because we wanted to be able to deploy it as a sidecar, which is what makes Kubernetes so powerful and so great, we made it ultra light and ultra fast. And what does this mean? It means that we built the data plane is tiny, tiny Rust proxies that, with a lot of requests, only take about 2 megabytes of memory per pod. All that while only adding about 1 millisecond latency in a 99th percentile. Well, if we think back to the diagram earlier, we have a control plane, and we wrote that with Go to really seamlessly integrate with the Kubernetes API, because that's where we're extracting a lot of the information from. It also supports H2, H1, gRPC, and TCP protocols. And we just released version 041 alpha last week. The goals we had with Conduit are, like, service meshes are a little complicated to kind of get on, like, what are all the things that I need to set up? And we wanted to have a zero config service mesh that we could offer that will add reliability, security, and visibility for Kubernetes specific applications. All right, it's demo time. If you want to follow along here or later, I'd encourage you to already install the Conduit CLI, which is easily, like, you need to have access to a Kubernetes cluster, so we can just run it in Minikube. That's what I'll be doing. And you just have to curl conduit.io install and pipe it into your shell, and then copy it into your path, but that's kind of all the instructions are there. And so what we're going to do is we're going to install an app into a Kubernetes cluster, just plain old app. And it's going to be failing some of the time. Not all the time, just some of the time. And then we're going to try to use the Kubernetes dashboard to see if we know what's going on, if we can get any indication of why our services are failing. But we're not going to have a lot of luck with that, unfortunately. And then we're going to install the Conduit control plane, following by installing the Conduit data plane into the application without having to take the application down. It'll just be a rolling update. And then we're going to use Conduit to trace the source of the error across the application so we can see what is going, like, to kind of identify the failing services and the failing edges. Now we're going to be so happy because we know who we need to talk to. So this is an overview of the app that we're going to deploy. It's an emoji voting app. It's a very, very complicated topology. I'm kidding. So it's a 4-service app. It's a web service that talks to an emoji service and a voting service, and the voting service in turn then talks to the emoji service to actually do the vote. We also have a vote bot that just is there to generate traffic, so we don't have to click ourselves the entire time. So if you decided to follow along, I hope you got to the point to installing the Conduit CLI. And then we're gonna go through the next steps of installing the control plane and actually injecting them together, like I'm also gonna do this live here. Okay. Let's hope this works. So I already installed the Emoji Voto app. Wrong button. And it allows us to vote for emojis. Sometimes it works and sometimes it doesn't. And even the same emoji, clicking multiple times, just starts working again. It's not very clear what's going on, right? So when we're trying to get our pods we can see that we have the Emoji Voto app deployed here, and then the regular thing. So it's working, it's running. And if we open the Minikube dashboard in the Emoji Voto namespace, we don't get any indication of things are wrong. Everything's at 100%, everything is great. When we click into one, like, it's all good. This is because all the pods are healthy. Like, everything is good, but we still see errors, right? And Kubernetes at that level doesn't know why, the calls are being made, the instances is up and running, but something is going wrong somewhere that we're just not quite sure how to figure out. On. So now we're going to install the Conduit control plane. And as mentioned earlier, we just have to run conduit install, and then we're just going to pipe this into kubectl apply. We can see that there's a namespace conduit that was created, so it's not doing anything in the default namespace or anything else. And we can see that we have a bunch of deployments and services that are being created. So Conduit also ships with a UI. And if we open the UI, we can see that it's telling us the service mesh was successfully installed, and it detects the deployments here. But it's also telling us that we haven't actually connected any of the deployments to the service mesh. So when we go into deployments, the links are grayed out, and we don't see any success rates or request rates because obviously we haven't actually injected proxy. So when we do that, this is the next step. We're installing the Conduit data plane. And what we're doing is we're getting the Emoji Voto YAML file that, is anyone following along that is actually doing this and wants me to pull up the bit.ly URL? Cool. So we're piping the output of just the YAML file into Conduit inject. And then the output of that just into kubectl apply. And we can see that a bunch of our services remained unchanged, but the deployments were configured. So what is going on here behind the scenes is that Conduit is taking the YAML file and is transcribing it and rewriting it and actually modifying it to add the Conduit proxy in the YAML file. So the user doesn't have to worry about, like, did I put this in the right spot? Is like the port the correct? Like, this is all being abstracted away from the user. So if we're looking at all the namespaces again, we can see that we've got some terminating and running again, and the Conduit namespace is still up and running. The emoji voter namespace is there. There's a bunch of changes being made at the moment. Now all the pods are up and running again, and we haven't actually needed to take down anything. So if we run Conduit dashboard again, we can see what changed. So now we can see the banner that we had that told us, you still have not connected your deployments. It's gone. And we can see all the deployments here, and we can see that the proxy status is green. And if we go into the deployments, we can see a high-level overview of the success rates, the request rates, and the latency distribution. And then if we decide that we want to take a look and check out, the emoji service, it actually opens a pre-configured Grafana dashboard that shows us the success rate, the request rate, as well as the inbound deployments and outbound deployments. But since it's a leaf service, it doesn't actually call any others. It just is there. And here we can see the voting and the web service as the inbound deployments. And if we just want to stay with the dashboard, we can actually we don't have to go back and click on all of them ourselves. We can just check out the voting service and check out the web service right there. Yes, I want to leave. So if we want to use the conduits, so Conduit, I don't know if I mentioned this earlier, ships with a CLI that also allows us to just dive into all the things that we saw and more. And so if we just run Conduit stat for the deploys, we see the same thing. We see the name of our services, and we see the success rates and the response rates and the latencies across the 3 percentiles. You might wonder why the vote bot is just showing dashes. That's because they're incoming requests, and the vote bot is just generating traffic. So there's not really anything that they're successful, but they're not being called. Okay, and we also see that really none of our services are performing that well. Like the highest success rate is less than 82%, which, as we saw earlier using the app, like it's not a good experience. You don't want your users to experience failures constantly, as well as you also don't want, as a user, you're not going to go to a site where you're just clicking, you're like, does it work this time? Does it work this time? And sometimes, it just seems completely random. You don't know what's going on. So we're going to start, so now we can actually just look into specific deploys and see what services are they talking to. And we're going to start with web just because it's the user-facing one. It's where we clicked. It's like we know web is running, but we just kind of want to know more. So we're just going to stat, and we can just add a from flag and pass it the deploy name. And here we can see that, yes, web does call the emoji service and the voting service, as we saw in the topology graph earlier. And we can see that the emoji service has a 100% success rate, but the voting service is only about 55%. So that would give us, so we'd be like, okay, well, what about the voting service? It kind of seems like the logical next thing to look at. And the voting service also calls the emoji service, as we saw in the topology graph earlier. And again, it's only about 50%, 52% success rate. Well, what we would want to do here is, you probably all have the graph in your mind, and it's a very small application, but we want to look at what are all the services calling the emoji service. Because there might be others than, just, we just want to know how are all the services performing that are calling our emoji service. And the way we can do that is, you might have guessed it, we have a to flag. I know, so creative. So yeah, here we can see the emoji service is called by the web and the voting service. And the web service has a 100% success rate. Yes, it's displaying all the emojis. But the voting service only has a 52, 53% success rate again. So we identified the edge a little bit of like something is going wrong when the voting service calls the emoji service. We're not quite sure what yet, but if you think about having an application with hundreds of services, now you at least know what edge, what kind of two services do you need to look at, which already narrows it down a lot more than when we just looked at the dashboard and everything was green, but we were clicking on emojis and it just wasn't working. So, what if we could just look at all the requests happening right now from one service to the other? We can. I know, surprise. And the wonderful command that lets us do this is tap. Tap allows us to just tap the request as it is happening. And we can tap from deploy, which just means all of the deploys talking it to a specific service. But we already identified that the error is happening between the voting service and the emoji service. So we're just going to set the voting service here. And we're just going to tap from voting to emoji. And here we can see all the requests that are happening, that the vote bot is generating at this moment. That's pretty cool, right? I think so. Thank you. OK, so let's investigate this a little bit further. Here we can see that the destination is the emoji service. And it's h1, it's a get method. We can see the path that it's calling. It's nerd face emoji. We can see the latency, and it's returning a status 200. So this seems to be all like it was a successful request. And here we can see that we have a 500 error. And we can see that it's also calling the emoji service, which we set it to the flag to only call the emoji service from the voting service. And we can see that something is weird in this URL. I don't know why there is a fail endpoint. I don't know, but there is, and we're getting a 500 back. So we know that there's this one endpoint that is being called for whatever reason, and it's returning a 500. We actually see quite a few of them. But the ghost emoji works, so that's cool. So now we see all of them, and we might just want to know, what about all the failures? Is there some sort of pattern that we could match? Because this is a small demo application, but in real life application, you might have more than one endpoint in that service that is being hit. So we can just grab for the 500s. And since it's a request, I also need to get the line before and the line after. So if we tap again, what this will do is actually just log us, or not log, just print us out the failing emoji requests. We can see here, they all have a status 500. And they all call this fail endpoint. So now we know Now we know what team we have to go to, right? We know that we have this team, the voting team, that is calling a fail endpoint in the emoji team that's returning a 500. So there's something of the team communication that we'll need to work on internally. But we can, yeah, we know where to look. We have a lot more visibility than we had just before, when you get a phone call because someone was trying out the application, or customer support was like, well, we had someone calling and like it didn't work, and I tried it and it didn't work and I don't know why. Like within a few minutes of just not having Conduit installed, well, I had the CLI installed, but not having it in our cluster at all, now we can see, like we have narrowed it down pretty rapidly. Okay, so just to iterate again, because I know there was a lot of commands that just went really fast. Just want to kind of talk about what we just did. We had, I already had an emoji photo app installed on Kubernetes without any service mesh injected. We saw errors when we were using it, but we saw nothing on the Kubernetes dashboard because it was just, our services were healthy, but something was wrong within them. Then we installed the Conduit control plane, or we installed Conduit, the control plane, and then injected the data plane. And we used then the combination of the stat and the stat commands to identify a falling call deep within our application's topology. And then we were able to go to the correct team and be like, what is going on? And we did that all while not touching any application code. We didn't need to add anything in any of the applications. We could just leave our editor closed. So in conclusion, debugging microservices is very fundamentally different from debugging monolithic applications. We all know that, I think. That's why we're here. And the service mesh is really uniquely positioned to provide that debugging information at a right layer of abstraction, because you don't want to be overwhelmed with information. But if you think back to the example request from the service bar to service foo, where it sits, it's just really uniquely positioned to extract all the information that we want. And it's super easy. I just did this, and besides a few type errors, like, it all went. And we didn't have to modify our application. I know I've said this a couple times, but I think it's really important, because having all of this in the application code means you have to also update it in every application, and then adding things to it. Like, this allows us to just leave the application code untouched. So, try it out. We have a booth that you can come visit if you have more questions, or if you want to get started or run through a demo. We also have a great getting started guide on conduit.io that you can just follow, that walks through some of the same requests, some of the same commands that I ran through today. And also, Conduit is 100% open source, and it works with Kubernetes version 8.1.8 and up. So thank you very much for coming.